Glad you're here for Unintended Consequences, Episode 20, for June 2nd, 2026. Today's case study traces how tools built to cut through digital noise ended up shaping what each of us actually encountered online, often without anyone noticing the change at first. The story begins in December 2009 when two friends sat side by side in a cafe and typed the same search term into Google. Their result lists diverged immediately. One saw established news outlets and institutional sources. The other saw activist pages and regional commentary that the first person never encountered. Neither realized the list differed because the personalization layer remained invisible to them. Recommendation systems had been introduced years earlier to solve the practical problem of information overload, yet they were quietly sorting users into separate versions of the same web based on prior behavior. Engineers at companies including Amazon, Google, and Facebook faced this overload after 2000, when the open web had simply grown too large for people to locate items they actually wanted without assistance. Collaborative filtering, first widely deployed by Amazon in 1998, used past clicks and purchases to surface additional relevant options. The approach felt like straightforward customer service at the time. It showed someone who bought hiking boots a tent they might need next, or pointed readers toward articles that matched topics they had already explored. By 2006, Facebook's news feed, and by 2009, Google's personalized search results extended the same logic to information itself. Designers assumed that greater relevance would increase engagement and satisfaction without restricting broader exposure. At the time, the dominant concern was noise, not isolation. Google announced personalized search results for all users in December 2009, drawing on 57 signals, including location and prior queries. Facebook refined its EdgeRank algorithm to prioritize posts from friends and topics users had previously engaged with. Netflix and YouTube adopted similar matrix factorization techniques to keep viewers watching longer. Early metrics showed clear gains. Amazon reported 35% of revenue from recommendations, and Facebook time on site rose steadily. These numbers reinforced the sense that the systems were working as intended. A few researchers, including Eli Pariser in a 2009 internal memo that later became public, noted that the same systems could limit serendipity, yet most product teams treated this as a minor side effect compared with the measurable lift in clicks. What made the limitation harder to spot was how gradually it accumulated. By 2010, Pariser began documenting that the same mechanism systematically removed opposing viewpoints. When two people searched BP after the Gulf spill, one received investment analysis while the other received environmental criticism, and neither saw the other's results. The causal chain was straightforward. Engagement-optimized models rewarded clicks on familiar material, so the training data grew steadily more homogeneous for each user. Over successive iterations, the models inferred stronger preferences than users actually held. This feedback loop meant that even modest differences in early clicks could widen into noticeably narrower feeds within weeks. Second-order effects appeared in political information. During the 2016 US election cycle, studies later estimated that roughly one-fifth of Facebook users received the majority of their news from sources aligned with a single partisan perspective. Users did not choose this narrowing. It emerged from the interaction between their past behavior and an algorithm that treated continued engagement as success. Third-order effects included reduced cross-cutting conversation offline, as people increasingly assumed their feed represented common knowledge. Pariser's 2011 book and TED Talk brought the term filter bubble into wider use, prompting platforms to add controls such as Facebook's See Fewer Like This option in 2011, and later, Why am I seeing this? Explanations. Google offered an incognito mode, and some users began deliberately clearing cookies, but the default experience stayed personalized. Regulators in the European Union later required transparency reports under the Digital Services Act, while some platforms experimented with chronological feeds during elections. None of these adjustments reversed the underlying data loop. They merely added user-facing toggles. The pattern matters because it shows how an optimization target defined solely in terms of individual engagement can steer systems toward reinforcing existing patterns for reliable short-term gains. Designers therefore benefit from measuring not only clicks, but also the diversity of sources or viewpoints reached over weeks or months. Simple feedback loops can produce large structural effects without any participant intending the outcome. The same pattern now appears in job recommendation and educational content systems, where helpful matching can quietly limit the range of opportunities presented. How might we test whether our own daily tools are quietly editing the world we see? That wraps today's case. The lessons travel further when you share them. Send this episode to someone who'd find it useful. We'll see you tomorrow. And before you go, this show is part of the NARA Network, a family of daily podcasts covering tech, science, markets, and more. If you enjoyed today's episode, give OmniView a listen. A balanced daily world news briefing that takes every side seriously. You can explore the whole lineup at neuranetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.